Hey kids, Flexing Teacher Weber here. I hope you're having a good day. So we have been using the Pythagorean theorem. Now in our previous assignment, we used the Pythagorean theorem when we were given right triangles and we had to determine the length of a missing leg or a missing hypotenuse. Today we're going to start looking at using the Pythagorean theorem in different problem-solving situations. So I've given the kids a page MP209 that has a bunch of problems on it, and we're going to do some of these problems together. So this is the page that I'm talking about. And the first problem I'd like to do is question number 3. And it says, a 7-meter ladder is leaning against the wall of a building. The foot of the ladder is 2 meters from the base of the building. How far up the wall is the top of the ladder? So this question is just screaming to me, draw a diagram. Drawing a diagram will just help us understand the problem a little bit. So let's draw the situation that we're looking at. I'm going to go to my slide here. This is question 3. And it says there's a ladder leaning against a building. So I'm going to draw the ground. And I'm going to draw a building. I think my building needs to have a door. And there's a window. Look at this big window. Oh, the sunlight. And we'll draw a person in that window. Smiling. Look at that. So there's my building. And the problem says that it's a 7-meter ladder leaning against the building. So typically when we lean a ladder, we lean it diagonally so that when you're climbing up the ladder, it doesn't tip over. So there's our 7-meter ladder, and I'll label that. That distance that we just drew is 7 meters. Okay, and the problem says the foot of the ladder is 2 meters from the base of the building. Well, when I think of the foot of the ladder, I think of the bottom. You better make sure this ladder's against the ground. So there's the foot of the ladder, and it's saying the foot of the ladder is 2 meters from the base of the building. So that distance from there to there is 2 meters. And the question says, how far up the wall is the top of the ladder? So we want to know, this top of the ladder, how far up the wall does this go? That's our unknown piece of information right there. That distance that I'm outlining in red is our unknown. Let's call that x. And as you can see here, we very clearly have a right triangle. There's our right angle, our 90-degree angle. And the hypotenuse is the side opposite the right angle. The hypotenuse is 7 meters. The one leg is x and the other leg is 2 meters. So we can use the Pythagorean theorem to figure out the length of how far that ladder is up the wall of the building. So the Pythagorean theorem for this question would state x squared plus 2 squared. The squares of the legs, add them up, equals the square of the hypotenuse. Keep solving our squares. X squared plus 4 equals 49. We want to isolate the x squared by itself and make this plus 4 turn into 0. So to do that, we can do minus 4, and that's quite all right, just as long as we do the same thing to the other side of the equal sign. This cancels off, and you're left with x squared equals 45. We want to know the value of x, so we'll take the square root of both sides. 45 is not a perfect square, so this is going to be an approximate answer. And the square root of 45 is going to be somewhere between 6 and 7. It is 6.708. We can just round that off to 6 and 7/10 meters. That's how far up the wall that ladder reaches, 6 7/10 meters. Okay, so to solve these kinds of problems, draw a diagram, see if you can find the right triangle, and then use the Pythagorean theorem to solve it. Let's do number 4 now. Number 4 says a ship left Shippagan, New Brunswick, and sailed east at 20 kilometers an hour for 2 hours, then south at 25 kilometers an hour for 1 hour. To the nearest tenth of a kilometer, how far away was the ship from Shippagan? Once again, using a diagram. So this is question number 4. And this is talking about directions. So let's remember our directions. I'll make a little... We've all seen this, right? Never eat soggy wieners, northeast, southwest. Now the question says, a ship left Shippagan, New Brunswick, and sailed east at 20 kilometers per hour for 2 hours. So after 2 hours, that ship has traveled east for 40 kilometers. 20 times 2 is 40. So for drawing our diagram, let's put a starting point here. Call it S for Shippagan. And we'll draw a line in that direction and say that that distance is what the ship traveled east, 40 kilometers. Okay, now let's look at our next instruction. It says, it then sailed south at 25 kilometers per hour for 1 hour. So it went 25 kilometers south. So we'll turn the ship and it will go down south. A little shorter line this time. Let's call that 25 kilometers south. Now the ship has ended up right here. Here's your ship. That is quite possibly the worst ship in the history of humankind, but it does the job. So there's where our ship is now, and the question says, at this point, how far away was the ship from Shippagan? So Shippagan is right here. The ship is right here. We want to know that distance. And you can see here we formed a right triangle. The right angle is right here. So the distance we want to know, that red line, which we'll call x, that distance is the hypotenuse of this right triangle, right? There's the right angle. The hypotenuse is the side opposite. So we can use the Pythagorean theorem to figure out that value of x. Let's do that over here. So the Pythagorean theorem would say x squared equals 40 squared plus 25 squared. Start squaring those numbers. X squared equals 1,600 plus 625. Add those up. X squared equals 2,225. Now we need to take the square root of both sides of this math equation to figure out the value of x. X is going to be approximate because this is not a perfect square, and the square root of 2,225 is 47.16. So we would round that to 47 and 2/10 kilometers. Oops. 47 and 2/10 kilometers. So that means this distance right here, the x, is 47 and 2/10 kilometers. That's how far away that ship is from Shippagan. Again, drawing a diagram and using the Pythagorean theorem. Okay. Okay, last question we're going to do together. We're going to skip to number 8. It says the base of the pyramid of Khufu in ancient Egypt is a square with sides 230 meters long. Calculate the length of the diagonal of this square to the nearest tenth of a meter. Let's draw a diagram, my friends. So if we're flying over the pyramid of Khufu, ancient Egyptian pharaoh and all-around great guy, you would see that the base of the pyramid is a square. And of course, a square has all sides the same, so all the sides of this square would be 230 meters. That's quite a huge pyramid. 230 meters, 230 meters. Okay, so that's the situation. The question says, calculate the length of the diagonal of this square to the nearest tenth of a meter, to 1 decimal spot. Okay, well, we haven't talked about diagonals, but we can probably guess that a diagonal goes from one corner of the square to the other, because that's a diagonal line. There's actually 2 of them, right? There would be one here as well, but it would give us the same answer. And you can see this divides the square into right triangles. Here's your right angle, right there. What we want to know is that red line, the diagonal. In this case, we're talking about the hypotenuse of the right triangle. Here's our right triangle. The side opposite the right angle is the hypotenuse. Let's use the Pythagorean theorem. X squared equals 230 squared plus 230 squared. As you can see, as we start to solve some of these problems, this is why I'm allowing the kids to use the calculator app on their phone or a calculator, because we're going to be dealing with some really, really big numbers and really big square roots. Not that they're not capable, but that's not going to be our focus right now. So 52,900 is 230 squared, and we have to do that twice, right? 52,900. Add those up, and you get x squared equals 105,800. Take the square root of both sides. And x is going to be approximately 325.26. Well, that's going to be 325.3 meters. That's that distance, 325.3 meters. Now, what's interesting here is look at that distance. 325 3/10 meters is almost 100 meters longer than the sides of the square. So that diagonal is almost 100 meters longer than the sides of the square. What does that tell us? Well, it's actually an interesting thing. If you're ever trying to pack something into a box and it won't fit, if you're able to, try packing it diagonally, because you'll get more space if you try putting it in diagonally. So, maybe you'll learn a little bit of math today, but this might also help you next time you're wrapping a holiday gift or a birthday gift. So the questions I'm going to give you today from this paper, your assignment is going to be to do question number 7. And in question number 7, the diagram is given. It doesn't show up well on this page, so but you can see here, there's diagram 7, and you want to figure out the value of x. There's a right angle there and a right angle there. And then you're also going to do question number 9. And of course, you're going to want to draw out a diagram for this question. So that's how we use the Pythagorean theorem to solve problems. We draw diagrams and try to find Pythagoras in the triangles. That sounded really deep. Pretty happy with myself. That's all for now. I hope that helps. Flexing Teacher Weber, out.